Okay, in part 3 of my notes on this subject, we are now going to take a look at the third form, and that third form is of the form the square root of x squared minus a squared. So remember, before it was the square root of a squared minus x squared. Now it's x squared minus a squared. Our substitution is going to be x equals a secant theta, and the derivative is going to be a secant tangent. Okie dokie. So let's go through and do a problem. So we can see from our problem that we do have the form that we are looking for. And so therefore we're going to let x be equal to a secant theta, where a is going to be 2. And so we end up with x is equal to 2 secant theta, and dx is equal to 2 secant theta tangent theta. The rest of this is pretty much the same thing as the last two videos. We're going to take out the x, put in 2 secant theta, square it, factor out the 4. Secant squared theta minus 1 now becomes tangent squared theta, another one of the Pythagorean identities. And now 4 tangent squared becomes 2 tangent theta. Now we go over here and we do our substitutions. We have our 2 tangent theta. Here is our dx is 2 secant theta tangent theta. And in the denominator we have x, which of course is 2 secant theta. All right, so now we need to simplify that. So we end up with the secants canceling out, boom, boom, and we get a tangent squared, and those cancel out, and that 2 comes out front. So we've done tangent squared before. One way to tackle this problem, we could use a reduction formula, or we could just integrate it. Change tangent squared theta into secant squared theta minus 1. And so then that, breaking that up into 2 integrals, as I like to do, we have 2 times the integral of secant theta d theta minus 2 times the integral of d theta. And so the antiderivative of secant squared is tangent, and the antiderivative of just 1 d theta is theta. So that wasn't too bad. So here is our antiderivative. That is our answer in terms of theta. And so, as always, we have to convert back into x's. So we make our right triangle. Our basic identity was x equals 2 secant theta, or secant theta is x over 2. And see, what do we need here? All we need is a tangent. We need a tangent here, and we need theta. Those are the 2 things I need. Okay, so that's what I'm looking for. I need a tangent. I need theta. Well, I've got secant. Tangent, then, once you've got all the parts of your right triangle, it's easy to figure out what tangent is. Tangent is the opposite over the adjacent. And then theta is, we're just going to take the arcsecant of that. And so theta is equal to the arcsecant of x over 2. Substituting those in here. And what did I do? I simplified it a little bit. And voila, we are done. That's it. That one wasn't too bad. I make up for it in this one. This one I had to write small. So we see that we have the correct form. We have a radical in the form of x squared minus a squared, where a is equal to 6. So our substitution is x equals 6 secant theta. D theta is 6 secant theta tangent theta. We take out the x, put in 6 secant theta. We square it. Factor out the 36. Take the secant squared minus 1, change it to tangent squared. Take the square root of all that to get 6 tangent theta. Now we do our substitutions. We have 6 tangent theta in the numerator. We have x cubed in the denominator, so 6x cubed. And dx is 6 secant theta tangent theta d theta. So we got a lot of 6's in here. We got 2 6's in the numerator. We got 3 6's in the denominator. That leaves us an excess of 1/6 in the denominator, so we get the 1/6. And so we got a tangent. Tangent is a tangent squared. That's secant, cancels with one of those, but we're left with 2 secants in the denominator. So we have a tangent squared over secant squared. Once again, try to get it all in terms of the same trigonometric function. I like to go for sines and cosines. So I take the numerator, tangent squared, and I think, well, that's sine squared over cosine squared. And then secant squared in the denominator is really 1 over secant squared, right? Because it's in the denominator. Well, 1 over secant squared is cosine squared. So that's where that comes from. It's reciprocal. 1 over secant squared is cosine squared. All right, well, now you can see, let's get rid of some of this now. We see that this cancels with this. And so all we're left with is the nice, very simple integration problem, 1/6 the integral of sine squared theta d theta. Well, we know how to do that. We use our formula, double angle formula, right here. 1/2 times the 1/6, can't read that, that's a 1/12. We integrate this, break it up into 2 integrals. And so we end up with this is our antiderivative. We've done those a bunch of times, so I'm just kind of skipping through it. And so now we need to convert those into, one more thing, I almost forgot. Sine of 2 theta again, got to get rid of that sine of 2 theta, change it into 2 sine of theta, cosine theta. So I think I did that. Yeah, I had 1 over 24. Now it becomes 1 over 12 because of the 2. Okay, so we have this. And we need to find theta. We need to find the sine of theta and the cosine of theta. So we start with our basic substitution. X equals 6 secant theta. So secant theta is x over 6. Secant is the reciprocal of cosine, which is adjacent over that hypotenuse. So secant is x over 6. So theta is the arcsecant of x over 6. Sine is the opposite side over the hypotenuse, so we get that. Cosine, as I just said, is adjacent over hypotenuse, so we get that. So we got everything we need. Put it all together, and I'm really kind of squeezing it in down here. And that should have been my answer, but I simplified it a little bit more to finally get this answer right here. So as you see in the last two, just like the last 2 videos, the process is exactly the same. It's just a different substitution. And one more. Find the area of the region between the graph of f of x equals the square root of x squared minus 9 and the x-axis over the interval from 3 to 5. All right, so we're doing an area problem. So let's start by graphing the area, just to kind of get an idea as to what we're doing. You can use Desmos. I haven't said that in a while. So here is my function. All right. And so we are bordered between 3 and 5. So that's my area. And so we can set up just a basic integration problem. We're integrating from 3 to 5. And so we want the square root of x squared minus 9 dx. And that is the form that we want here. And so my substitution is 3 secant theta. Dx is 3 secant tangent. Do all the substituting. We get 3 tangent theta. Plug that in back up here. Times my dx. 3 and 3 is 9. Tangent squared secant. Tangent squared is secant squared minus 1. Okay, so again, we're trying to get everything in terms of the same trigonometric function. If you got tangents and secants, use the identities. If you have cotangents and cosecants, you can use identities. Depends on what functions you got mixed together. All right, so secant squared theta minus 1 times secant theta is secant cubed minus secant. We've done secant cubed before, I believe. Now, we've done that a couple times. And I believe we did that using the reduction formula. And so secant cubed is all of this. That's the secant cubed. Then 9 minus secant theta, that one we know. That one is like right here. Log of secant plus tangent. Now, we also have to change, this is a definite integral. Just like in the last video, we have a definite integral, so it's handy to change the bounds. If I change my bounds from x values to theta values, then I don't need to go through and do that right triangle process to convert these things back from thetas into x's. Save myself a little time. So we know that x is equal to 3 secant theta. That comes from our definition over here. Or theta is arcsecant x over 3. And then substituting in 5, we get theta is arcsecant of 5/3. And substituting in 3, we get theta is arcsecant of 1. So these are my two bounds. So that's where these are coming from right here. Let's go blue, purple. If you can see, though, those are the bounds. Arcsecant of 5/3, arcsecant of 1. And needless to say, that's not going to be a lot of fun to do. Go ahead and use Desmos to do that if you want. And we're going to end up with area is equal to 10 minus 9/2 log of 3. Okay, I believe that is it for section 3.3. A lot of real challenging problems in this section. Section 9.4 on partial fractions, we continue with the fun. And then it gets a little bit easier after that. It's the first 4 sections of this 7-section chapter that are really quite rigorous. All right, have fun. See you in the next video.